All right, so we're going to pick up at number 30. F of x equals 1 minus 3 sine of x plus pi. So again, I'm not going to write like step 1, step 2, but I'm still going to do those things down in order. So what's the very first thing?
Finding the amplitude is negative 3.
No, absolute.
Oh, absolute value.
Amplitude is 3. What's the period?
2 pi over
2 pi over r. There is
over
no
b.
No r.
Over b, I think it's pi.
It's 2 pi over the number in front of x, which is 1. So 2 pi over 1 is just 2 pi.
Been a long day.
The scale would be what?
Pi over 4.
2 pi over 4, which is pi over 2. And then what else is happening to this graph?
It shifted up 1.
Up 1. And it doesn't matter which, if you do up first or
And it shifted right, left 1.
left pi. In here determines left or right, and it's opposite the direction of the sign.
How did we get the up part again?
Because of the one, it's like,
Oh, okay.
if
You're
you
saying
write
you.
it out in a different way.
Okay.
All right. Is anything else happening to this graph?
Is it reflected?
It's reflected. Okay, now, if you had a hard time seeing this, we could have rewritten this equation as negative 3 sine of x plus pi plus 1, like this. Okay, and that would put it in our, like, I guess you'd call it standard form, so that you can see it better. Because, like I said yesterday, none of y'all did it, I don't think, but some people would try to say the amplitude was 1 in the original form, which is not the case. So if you need to rewrite it, rewrite it. All right, so we haven't had one that we actually were graphing that was reflected yet, so it'll be good practice on this one. So I've got an amplitude of 3. I know it's going up 1, so I'm going to go to 4 on the y-axis. Period's 2 pi. I'm counting in increments of pi over 2. And I know that I'll be going left pi, so that means that I need to do some markings on the left side for this one. I need to go all the way to negative pi since I'm going to be going left pi. So regardless of what the function is and what's happening to it, my very first graph is always just the baseline if nothing was happening to it other than like the amplitude and stuff. What am I doing? So I start where with sine? Starts at 0, and goes up to 3, back to 0, down to negative 3, and back to 0.
Is it only on cosine when it starts at 3?
Yeah.
Right, okay.
So I mentioned this yesterday, but like I said, we haven't had one that this happened to yet. Or well, maybe we did. I don't know. Anyways, but one that's being reflected and shifted. I know we haven't had that. We may have had one that was just reflected. But if a graph is reflected and shifted, I would do the reflection first. Okay, because otherwise it can get confusing, and I see people end up getting their graph wrong by waiting. So I'm going to reflect, and then in one graph after that, I'm going to do both shifts at the same time. Okay, so the reflection is over the x-axis, so it's flipping upside down. So that means that I'm going to have this point here at 0 stays at 0. This point that was at 3 is at -3 now. Point at 0 stays. The point at -3 goes to +3. And then the point at 0 stays. So now my graph starts by going down rather than up. So it looks like that. It's in red for me. And now I'm going to shift the graph. So what I do is I will do like the left shift and then up, but I'm going to do it all at the same time, okay? So this point that's here at 0, I'm going left pi, so that's 2 spots because our scale is pi over 2. So it's over here to pi, and then it's up 1. So instead of it being at 0, it's up here at 1. So that's my first point. So I've shifted this 1 point over pi and up 1. This one that's at pi over 2 down here, I'm going to go left pi, so that's going to put me at -pi over 2 and up 1. And if you want to do it in separate graphs, that's fine, but I usually will get to where I'm just doing these ones this way. This point here, that's back at pi and 0. It's going to go left pi, so that puts it here, and up 1 right here. You can just put it right there. Thanks. This point that's here at 3 pi over 2 and 3 is going to go left pi to pi over 2, and it's going up 1, so it'll be at 4 now. And then this last point is at 2 pi. It's going to go left to pi, and then up 1. And I'm going to connect. And so this purple is my final. You can just start it there. Now, when you get more comfortable with it, okay, you don't necessarily have to graph the initial graph that I had in blue. Okay, I know that sine starts at 0 and goes up. So if it's reflected, what do I know has to be the case? It starts at 0 and goes down. Okay, now with sine that's okay. With cosine, that's where people tend to mess it up when the cosine one is reflected. So I would probably start with the baseline function. But like on this graph, a lot of times I would only have 2 things. I would have what's in red and I would have what's in purple. Okay, but it's up to you what you need to do. If you need to do 4 separate things so that you get everything taken care of, that's fine. But if you can do things at the same time, as long as you get to the right final answer, you're good. Any questions on that one? All right. I'm going to do one more graph. I'm going to do a cosine one. F of x equals negative cosine of x plus pi over 2 minus 2. Quick question. In your notes, did you have the parent function for tangent? Yes. Okay. You didn't just have sine and cosine, right? Okay. All you need to know for tangent is the parent function. We're not going to do any other ones with tangent in here. Next year we'll do like a couple, but even then it's predominantly sine and cosine next year. So that's why we focus on this. On the AP exam, the short answer question is sine and cosine. So, all right. What's happening to this graph? Or what's the first thing?
Amplitude is 1.
Amplitude is 1, period.
2 pi.
2 pi, so the scale is,
Pi over.
yep, pi over 2. So since we have already done, obviously, 2 pi, I don't need to show that it's 2 pi over 4. If you want to, you can, but I can just go straight to pi over 2 as the scale. What else is happening to this graph?
It starts down to.
Goes down 2. What else?
Move to the left, pi over 2.
Left pi over 2. And it's reflected. Good. All right, so I'm going to show you this one without graphing the parent initially. Okay, or well, I will graph the parent one so that we see it, but then I'm going to erase it and I'm going to show you if you just started with the reflected what it's going to look like. Okay. So I'm going to set up my graph over here. So I know it's going to be going down 2, so I just have the amplitude of 1. So I'm going to kind of space them out a little bit better than I do sometimes, just so that I can see everything. I'm going to go ahead and scale my x-axis, and I know that it's going left pi over 2, so I'm going to go on the left side of the axis there, just to minus pi over 2 is all I need to do. Now, on the y-axis, I don't normally write that I'm like counting by ones. If you're counting by something other than 1, you need to specify, okay? I mean, typically they're not giving you anything where you shouldn't, I mean, you should pretty much just be scaling by 1. For the sake of what we're doing, they're not giving you any really big amplitude values, so I think the biggest one I've seen is a 4, so. And they're not being shifted up or down that significantly. All right, so I'm going to graph the parent first, but then I'm going to erase it, and I'm going to show you if you didn't do it, how we would just go straight into the reflected graph. Okay, so where does cosine start?
Amplitude.
At the amplitude. So in this case, it's at 1. And then it goes down and back up. So it kind of looks like a V. Oh, as I'm about to make it pointed, and I'm not supposed to do that. What is happening? Round it off. Okay. All right, so that's what it would look like there, okay? So it starts at the amplitude and it goes down. Actually, I'm just going to leave it. I'm not going to erase it. All right, so reflected would be next. So if it normally starts at 1, this would be at -1. And it would start by going up. Normally we start by going down, so if it's reflected, it starts by going up. So you could do this part first, and then it gets up to the amplitude on the top side and starts coming back down. So that would be the reflected one there. So sometimes I will start there, and I won't even do what I did. I just erased the wrong one, didn't I? I'll start there, okay, instead of starting with the parent. Totally up to you how you want to do it. Now, I will do the shifts in 1. So we go left pi over 2 and then down 2. So this first point here, left pi over 2, down 2. Here, left pi over 2, down 2. Left pi over 2, down 2. Left pi over 2, down 2. And left pi over 2, down 2. And so notice, even though I've shifted it, it still looks exactly the same. And I've got my 1 full cycle. How are we feeling about these so far?
Good.
Time consuming, annoying, good.
A lot better than last section.
Not annoying.
Last section
Very
was
annoying.
this exact same thing.
Really?
I meant like last chapter.
Oh, I was like 14.1 literally went with 14.2. All right, the last thing we have is actually writing equations. So 42. The graph of y equals the cosine of 2 pi x translated down 4 units and left 3 units. So we're taking this initial function that they gave us, and then we are basically adding on the pieces of where it's going. So this one's going down and left. So I would suggest doing the part that would be in parentheses first. Okay, so that would be y equals the cosine of parentheses 2 pi x, and then what does the left 3 say that it's going to look like?
Plus 3.
Plus 3. And then it's translated down 4. So then minus 4 out here. So again, this is a much easier version, but this is training you for part of what's on the AP Pre-Cal exam next year if you take that, okay? One of the word problems that they guarantee that you have, okay, assuming they don't change the exam next year, but they didn't this year, so I don't know why they would. But anyways, one of them is a trig graph word problem, okay? And so basically, they're going to give you some points, and you're going to have to explain essentially what's happened to it, if it's been shifted and how much, and you're going to be writing the equation that ends up looking like this based on what you're given on the graph. Okay, so just things that this is kind of like in steps getting you ready for that. So we'll do one more of these ones. Let's see, 46. I'm just going to write the graph of y equals the 1/2 sine of 6x, and I'm just going to write down 3/2. I don't want to write the whole thing. And write 1, then reflected, and I'm going to write it how they do, but I'm just going to tell you that it doesn't change anything in the line y equals -3/2. Okay, now, the reason that they write it this way, okay, is because the graph has been shifted down, okay, and so then they're telling you that it's reflected over that spot where it was, okay, like over the center line. So if it went down 3/2, that means my center line went from 0 to -3/2. So that's why they're telling you it's reflected over that. And it's only because they tell you that it's shifted down and right, and then it's reflected, okay? It doesn't change anything about the way it would look if you graphed it, if we reflected it first and then shifted it, or if we shifted and then reflected, okay? So that's why it's written that way. Just in your brain, if that's confusing you, just go, it's reflected. That's all you need to know, okay? So, how would I write this one?
Y equals -1/2.
-1/2 because it's reflected, yep.
Sine parentheses 6x minus 1.
Yep, because it's going right 1, so that's the -1 inside.
And the parentheses minus 3/2.
Yep, -3/2 outside because it's going down 3/2. All right, I'm not giving you a ton of them because obviously I know they do take time. But if you feel like you're struggling or need to do a few more, obviously you should do that. So, let's see. 13.
This is on top of the problem she gave us.
Yeah, you did them right.
17. Yes, those were like 5 problems from 4.1 where you're not graphing anything, you're just writing them. Let's see, 19. I'm trying to give you like some that are sine and cosine, so I'm trying to make sure. 13 is sine, 17 is sine, 19 is cosine, so we need another cosine one. 29. 31. So that gives you some sine and cosine and a sine and a cosine one that have been reflected. And then 43 and 45, which are the two that you're writing the equations for them. So you have the rest of the time, just shy of 30 minutes, so you should have plenty of time.